Good morning, everybody. Yes, Professor Hasse has the COVID virus. Tested positive Saturday morning, feeling very well. My wife isn't doing very good, but I feel fine this morning. But university requires a 5-day isolation period from the campus. And so here we are this Monday and Wednesday. We'll be having our course via the Zoom experience. And thank you all for responding and coming on time today to this mandatory class today and Wednesday. You're not here, it affects your grade. So I appreciate all of you being here. I'd really appreciate all of you if you would turn on your cameras, but it's not mandatory. So if you don't want to turn on your cameras, you don't have to. It just makes it a little bit more pleasant for me to teach instead of into a black hole, at least looking at some faces, but no worries. So again, this week, number 6 of our 15-week semester will be taught via Zoom, but nothing will change. The lectures are exactly the same. The work stays the same. And matter of fact, it's even better off for you all because you're safer. You don't have to get any potential diseases from your professor or from anybody else. So I appreciate that. This class is also being recorded if any of you would like to go back and view it after the class is complete. So where are we heading into this week number 6? We're beginning our discussions of describing data in the form of different types of plotting of graphs, displays, measurements of position, percentiles, and that's what we're going to be describing this week in chapter 4. Leading up to a week from Wednesday, our midterm examination in week 7, which will be on chapters 1 through 4, our midterm examination. The midterm examination will be in the 2 parts. The first part will be in class on Wednesday, October 5th for about an hour, hour and 15 minutes in length. That portion in class will be a combination of multiple choice and fill in the blanks and definitions. The second part, which will be take home, which will be given that Wednesday as well, due on Sunday, the following Sunday, will be about 3 or 4 problems from the first 4 chapters that I will ask you to do and calculate and show, either however way you want to do it, either in a digital platform like a spreadsheet or in a Word or PDF document, or you can just write out on your own the answers on a piece of paper and then just submit them, bring them to class on that following Monday. But the midterm will be a 2-part examination beginning Wednesday, October 5th. The first part will be in class and the second part will be a take-home. And that's what we're leading up to with our discussions this week. You all had some problems to do to post by last evening. Most of you have done that. Some of you have not. And I have not received any extension requests. So those people will naturally get 10 points off their grade if they do submit it. And since we don't have all the work posted today, I will review quiz number 2 and those 2 problems Wednesday in class. So that's where we are officially and unofficially at this point in our class. Again, I apologize for the inconsistency of coming to Zoom, but I think we'll cover the same material. It should work out fine. Okay, so with that being done, let's go to Blackboard and see what we got going on in Blackboard this morning. Okay, so we're beginning at week 6, the file folder for week 6. There's our learning assignments for this week. Again, both classes this week are on the Zoom platform. We are to read chapter 4 this week, and we will be reviewing exercises 1 through 5 and 11 through 13 this week. These will mirror some questions you'll see on a practice quiz, which will be posted and given to you on Wednesday and due next Sunday, very similar to the one you did last week. These two quizzes of the last 2 weeks will prepare you, along with the first quiz, to as review items and as study guides for the midterm, which will be next week that I just described. So as we can see, the week is set up for a discussion of describing data, dot plots, stem and leaf displays, measurements of position. What percentile is the data in? A box plot, coefficient of skewness. Good Lord, so it's like I'm talking a different language in English. But those are all ways of, again, describing statistical data that we are learning how to calculate and put together in different formats, different graphs, different ways of acknowledging. Instead of a frequency distribution, we put the thing, what you're in the 50th percentile of the data. In other words, half the data is above where you're at. You're in the 75th percentile of the data. That's measurement of position, how to do a percentile. When somebody tells you, oh, you're in the 90th percentile of your class. Wow, that must be pretty good. How do they calculate that 90 percentile of being in the class? And that's what we're learning about in chapter 4, different ways of describing statistical information. And these exercises, and for you who do not have a textbook, this is a printout of those exercises, 1 through 5, 11 through 13. And we'll begin to review those today in class and also on Wednesday. And these are, again, our examples of these various different ways of describing data in statistics. I think one of the most main important things of statistics is not so much where the data comes from. That is very important, but also how you show the data. So the reader or the person who's trying to interpret the data can understand and explain what the data is what kind of information you're getting from that. Your income level for your family income is in the 95th percentile of LA County. Wow, you must make pretty good money compared to a lot of other people. What does that mean? Well, it means you're doing okay. But how do you interpret that, or where did that come from? That's what a lot of this describing of data of chapter 4 is all about. How to interpret information, and we've continued to do that. We started it last week, and we're continuing it on this week, heading into our midterm examination. Remember, we have a student discussion forum. If you have any questions or concerns, you can post to that discussion forum if you need any information, especially this week when we're into Zoom. I know students like to hide out in the Zoom environment. They don't really, I don't have to show my face to the professor. I can just hang out and listen and do what other things I'm doing at 7:40, 7:55 in the morning. But if you have any questions and need to answer or have answers to problems, if your cumulative average or your grade point is not what it should be, please let me know. And you can do that without even contacting me via email. You can just post a question to this discussion forum, and I can answer it directly to you. So please remember that. Again, as we do our videos this week, they will be posted to the Zoom and YouTube video links file folder in Blackboard. Here's last Wednesday's class recording. And so if you want to go back and review data or look at it, geez, I have the same shirt on as I had last week. What a slob. Be that as it may, this is where I post the videos for that I do record in class. And you can go to this area Naturally, they're posted in also the week that they occurred in, but a summary of all the videos that I post for our class lectures will be in this Zoom and YouTube video links file folder. And remember, if you have not done so, make sure you post quiz number 2 for chapter 3, questions, exercises 17 and 18 to this file folder if you have not done so, please. All right. So that's up to date in our Blackboard and where we stand. Again, Blackboard is a very informative area to get information, to get review. If you have open items or questions, also Blackboard is an area where you can see your grade and how you're doing in class. Speaking of the grades, as we approach the midterm in week 7, I file midterm grades with the registrar's office. These are unofficial grades. I mean, they don't go on your transcript. They're just an idea to the students and to the registrar and to your academic advisors on how you're doing at the middle point of our class, week 7. And you can get an idea of your grade average. If you're having issues with attendance, I let them know about that. If you're not, if I don't seem to know what you're responding to anything, I let them know about that. But all in all, this class is doing excellent. But if you do, I do post midterm grades next week after the midterm, and the copies are sent to you all and to the to your academic advisors, just so you get a good idea where you stand I guess you could say unofficially in class, because these grades do not go on your transcript. They're not reported in any shape or form as part of your overall grade point average. But it gives you a snapshot through the midterm of where you stand in class. Okay, so that's where we are administratively up to this point. Now let's take a look at some of the key topics of Chapter 4 to note in your notes, and which will be highlighted in the exercises that we review later. As we were talking about a few minutes ago, one of the areas of study of describing data is different ways of putting data in a format. In statistics, it's naturally to put a lot of things in graphs and plotting them, plotting points on a graph and see where those points show up in relationship to other points, other variables in your analysis. And one of those ways is called a dot plot. It's a good way of comparing two sets of data, like the number of vehicles serviced last month in these two different dealerships. Here's the different vehicles that was served by one Ford dealer compared to a Sheffield Motors dealer, and the amount of vehicles that they serviced during the course of the week of the month. And then you plot them like this. You can do this very easily in Excel, but not really necessary, and I'm not requiring you to do a dot plot in this class. But I wanted to show you that if all of a sudden somebody said, oh, here's the number of vehicles serviced at these two dealerships in the last 24 days, you can notice that the dot plot is the number of vehicles on specific days and how it showed up in this area. And it looks like, as you can see, some certain days are a lot busier than others. And you can also see that one dealership has more vehicle service at the beginning of the period, and the other has more vehicle service at the end of the period. You can just get a feel for the data. That's what a dot plot tells you. It gives you a different way. Instead of seeing rows and rows of numbers like we did, it can show you the calculation. And as you can see here, down here, we put down the mean of the information with the averages for each of the dealers. We can also put down the median. We also can put down the percentile, quadrants. percentile 1, percentile 3. We'll talk about that a little bit later. And we're also talking about the standard deviation, how the plot or the variety of numbers differ from the mean. And we'll talk about that a little bit later as well. But again, this is called descriptive statistics, and we're putting all this information into a plot so you can just see graphically how that looks. And that's an idea. This is a perfect slide of what a dot plot is, but also giving data on a series of information, in this case, vehicles service. Now we're going to talk about the percentile. And of anything, one of the few skills or disciplines that you'll take out of statistics, especially this class, business statistics, is how to measure a location by percentile. In business, this is done all the time. At University of La Verne, this is done all the time. Professor Hasse is in the 80th percentile of positive student evaluations. What does that mean? It means that 20% of the faculty have better student evaluations than Professor Hasse, and 80%, and there's 80% up to that point, they have about the same, or he has better. So the location of a percentile is a common used calculation and number used to determine where you stand. And it's all based on naturally 100%. Quartiles are divided by 25%, 50%, 75%, 100%, and where you stand. So to determine the where you are in a percentile, you have to take the number of observations and put them into a set of 100 parts. And this is what this means. So, for example, Morgan Stanley is an investment company with offices located throughout the United States. Listed below are the commissions earned last month. We've looked at this before. Now I'm sorting those commissions by smallest to largest. The lowest commission is $1,460, and the largest is $2,406. This is from a sample of 15 brokers. Now let's find the median of this area. So what is the median of these numbers? First of all, we can go back and see. There's 15 numbers, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it looks like the median is 2,038, which is at position number 8. All right. That's the midpoint or the median, not the mean. That's the midpoint of these series of observations, 2,038 of commissions earned last month. So that now if we wanted to find the first and third quartiles or percentiles, that means 25% is the first, third is 75%. We want to go to the fourth number and to the 12th numbers, okay? In other words, what is the percentile? So if we have 15 officers or 15 observations, we add 1 to that, that's 16, and then we multiply it by 25 and divide it by 4 equals 4. And so we go to the 4th position. 1, 2, 3, 4. So 1721 in commissions is in the 25th percentile. And 12th position, 2,205 monthly commissions is in the 75th quartile position. So we take the data and organize it and find, in this case, if it's the first quartile, that's 25%. We go to the 4th number. The third, 75%, we go to the 12th number of the data, and that's what percentile you're in. So that's how they calculate. You're in the 90th percentile. You're in the 25th percentile. You determine the number of percentile you're looking for and find that value in the series of information that is given. Then we have what is called a box plot, okay? a box plot. So we looked at a dot plot, which is dots of all the data. We've looked at a percentile, which kind of organizes data into a percentile. Now we're looking at a box plot. What does that mean? A graphic display that shows a general shape of a variable's distribution based on 5 descriptive statistics: the maximum and minimum values, the first and third quartiles, and the median. Remember back here, when we looked at the plot, we're looking at different descriptive statistics. And we're looking at the high and the midpoint. We're looking at the median. We're looking at the mean. These are the descriptive statistics of this dot plot. Then we break it down into a percentile. Now we're taking a look at those 5 key statistics and organizing it into a way that we can see where they are in relationship to each other. Remember, if I mention to you, and here's a great question for a multiple choice question or a fill in the blank question on a midterm, what are 5 common descriptive statistics? Well, one is the maximum value. What's the maximum value that you have as a variable? Another is the minimum value. What is the minimum value in a row of variables that you've observed? What is the first quartile, the first 25th percentage? What is the third quartile, the 75th percentile group? And what is the median, the midpoint of this data? These are 5 examples of descriptive statistics, that 5 different ways of explaining some information. So notice here, if we put this group of information in an area, it's a minimum value, and its maximum value. We're putting this information into a box where these 5 descriptive statistics fall into. Gives us a little bit of a concentration of where the information is. It's called a box plot. Here's an example. Alexander Pizza offers free delivery of its pizza within 15 miles. How long does a typical delivery take? Within what range will most deliveries be completed? So there's the key. The reason why we do a box plot is we want to see when the majority of the information falls in. That occurs within that box. And that's what this question is being asked by the pizza company. What range are most deliveries completed? So using a sample of 20 deliveries, they have 13 minutes of a minimum value of a pizza delivery time. In the first quadrille, or 25%, it's 15 minutes. The median is 18 minutes. The midpoint of all the delivery times over these 20 deliveries is 18 minutes. The 75th quartile, or Q3, is at 22 minutes. And the maximum value is 30 minutes. Well, as you can see, the reason why you're going to do a box plot is you're going to show where the midpoint is of your deliveries, of these 20 deliveries, which is important. But also, from 25% to 75%, where's the majority of the time it takes to deliver the pizzas? So here we are putting it right here. Remember, our minimum value is 12 minutes. Maximum was 30 minutes. And then we'd have the median as 18. We have the first quadrille as 13 minutes. The first quadrille is 15 minutes and the second is 22. And so you can see where most of the deliveries take place, from the minimum to the maximum. But as you can see, the average, or the median, is 18. So it gives you an idea where the time span between 15 and 22 minutes, that's where most of the deliveries are taking place. And that's where the midpoint is. So it tells the pizza company how long it takes in somewhat of an analysis of a sample of 20, what time involved in delivering the pizzas. I know this sounds like a stupid example, but it can be used in any example. Now, one of the points or the key points of chapter 4 is how data is shown, okay? And it's kind of like the shapes of the data. It's called skewness. Remember, data and the amount of times it happens over a period of time in relationship to the median and midpoint of that data is called the bell curve. And notice here on the far left, this is what is called a simple bell curve, where most of the information is occurring around the average. And as the data goes out, it becomes less relevant and becomes less frequent the farther away you get from the average. This is called a normal bell-shaped curve. In statistics, you want most of the data to appear this way. Half the data is on one side of the average, half the data is on the other side of the average, and they all are uniformly similar. This is called, which we'll get to a little bit later in our class, a very important concept of statistics called the central limit theorem. Don't have to write that down now, but that's what the central limit theorem says, that if data is done or data is accurate, it's going to follow along these lines. But then, like in all things in life, things are not always according to the averages or to plan. And so sometimes you might see data that is positively skewed, which is greater. Most of the data is on the one side of the average. Or negatively skewed, where most of the data is on the other side of the average. And then something that is bimodal, which the data is really wacky compared to the mean or average of the median point of the data. So you sometimes have data that is indifferent. Now it's the interpreter, you, the statistician, that has to tell whoever this data is for, is that, okay, in this case, we have great data. The bell curve is uniform, all is well. But sometimes you do an analysis where the data is a little bit off. That doesn't mean the data is wrong. It just means that due to the nature of the question and the observation, it's going to be skewed one way or the other, or totally bonkers. And you have to understand that. What does it tell you about the data, or maybe about the question or the information that you're asking? And that's what we call the shapes of frequency, or the skewness. If I say something is positively skewed, that means the higher part of the data is to the left of the average. Negative, the direct opposite. And that's what they're talking about here. So just to review, we started out with a dot plot, which is organizing data into a series of points on a chart. Then we see where that fits into a particular percentile. What's 25% of the data? What is 75% of the data? What is 90% of the data? And finding that point in that series that goes to that area that tells us the 4th, the 12th, the 15th position is those specific percentiles of that data. And then what is a box plot, where we organize descriptive statistics into one area to see where the concentration of the observations are. Different ways of explaining data. And then finally, is the data common? Is it oddly shaped, both in a positive or negative, or even bimodal way? What does that tell us about the observations and the information we're looking at? So that's the key main points of chapter 4. Now I want to take a look at some problems from the chapter beginning today. And let's take a look at those problems. They're at the end of your chapter. And let's see if we can go over some of these. And these are kind of a refresher for some of the problems you'll see in your quiz later on in the week. But this is a good way of describing some of the definitions of Chapter 4, Describing of Data. And the first question is, describe the differences between a histogram and a dot plot. First of all, what is a histogram? That's a key point. Well, a histogram describes a frequency distribution using a series of adjacent rectangles. You might have seen this in your review of Chapter 4. A dot plot puts the data in individual observations. Remember, the dot plot was one observation, there's a dot. Another observation, there's a dot. A histogram creates triangles of data summarizing groups of data. When might a dot plot be a histogram? Probably not very often, because dot plots are taking individual information and putting them into specific reference points. Now, question 2, and this is something, again, you should go back and look in your reading, is what is a stem leaf display? What is a stem leaf display? Describe the difference between a histogram, which is a series of rectangles showing data, and a stem and leaf display. Well, stem and leaf display is showing information going off into their specific brackets, and it shows the dispersion of the data. Now I'm going to go back to the chapter to show you an example of this. Here we go. Oop, there we go. Okay. Here's 3 examples of data that's kind of all over the place. One isn't, but some is. It's called a scatter diagram. Okay, it's a plotting of data into various into questions. And one question was the business maintenance cost on the age of a bus. Naturally, as you can see, the older the bus gets, the more you're going to spend on maintenance. And notice it's pretty consistent. When a bus is new, very little cost. And then as it gets older, it's pretty uniform into a straight line of how that works. Here's another chart taking a look at home runs versus batting average. Having a high batting average does not necessitate hitting a lot of home runs. And so naturally, this is called a scatter graph because the relationship of batting average to home runs is not consistent. It's not uniform. It's kind of all over the place. Oops. Sorry. Hit the wrong button there. Excuse me, guys. There we go. And here's another one, which kind of like right in the middle. Housing price versus days on the market. And in this case, it's taking a look at how long a house is on the market and then the selling price or the asking price of that house. Notice the asking price of a house is quite high in only 25, 26 days on the market. And the longer the house is on the market, the housing price drops because this owner is probably trying to find a seller and is reducing the price. It's a little scattered, but it's kind of consistent pretty well right down through the middle of that line. So here are three different types of scattergrams, or three different types of information. One where the data is pretty consistent and uniform and bus maintenance over age. Another where the batting average means very little to how many home runs a batter will hit, so it's all over the place. And then it kind of makes sense that the longer a house is on the market, the lower the price becomes, because the seller is trying to find a price in the market so they can sell the property. So it's a little scattered, but it's pretty consistent. As you can see, it's uniformly going down as time goes on. So these are indicators of data. And if we would take a look at this, we would say, well, one thing we know from this analysis, that batting average has nothing to do with home runs. I think that's a safe assessment. But another interpretation we can make from this is that the older a bus gets, the more maintenance costs are going up, and the longer a house is on the market, I think it's consistent to say the price is going to drop. So as an interpreter, that's how you would explain that information and showing in that context. This is what we call a stem leaf display, where you can chart these specific areas of the chart by where they go off by. Let's say you want to look at the first 25 percentile, which might be batting average of 248 or something, and you can graph it in that percentile or that quadrille. And then you might take a look at the 75th percentile, where that fits in, and then have a chart going off into those different. You kind of the stem is the quartile, 25%, 75%, and then the display is where those points fit and in that area of that quartile. So that's what that means. But more specifically, it's how you interpret the data. And I think that doesn't require too much thought. By just looking at these three, you can pretty well figure out what the analysis is trying to point out, that you own something longer in regards to a bus, you're going to have pay more maintenance. If a if a house is on the market longer, usually the price is going to go down to the seller. But there's no correlation between batting average and home runs. So I think that's what the showing of this data is trying to prove. Okay, good. Okay, well, let's look at chart number 3. Now, this would be a question you might see Wednesday or even on the midterm. Question number 3. Consider the following chart. Okay, we got 1 through 7, and the number of points occurring at 1, 2, 3, 4, 5, none at 6, and 1 at 7. What is this chart called? It's a dot plot. Okay, no, not too much mystery there. How many observations are in the study? Well, we got 2 at 1. We got 1, 2, 3, 4, 5, 6. That's 8. 4 more. That's 12, I think. 1, 2, 3, 4, 5. That's 8, 10, 12, 13. Okay. So just how many points there are? 7, 11, 13, 14, 15, excuse me. 15 observations. Okay, I just counted up the number of points. What is the maximum and minimum values? In other words, we're trying to get descriptive statistics here. Well, the maximum value looks like 7, and the minimum value looks like 1, right? Around what values do the observations tend to cluster? Well, it's pretty obvious. Looks like 2 and 3. You got 1, 2, 3, 4, 5 here and 4 here. 9 of the 15 occur between 2 and 3. Okay, nothing really rocket science there. If we would want to find the mean of this, we would just take these number of observations and relate it and divide by the number of 15 divided by 7, and you would get it'd be around 2 point something as your mean. Your median would probably be around 3, 2.5 or something. But here we're just gathering data about a dot plot and what it tells us about the observations and the results. It's called a dot plot. Now let's look at question 4. The following chart reports the number of cell phones sold at a big box retail store for the last 26 days. Okay. Take a look at it for a minute. It's like a lot of cell phones in the midpoint and also one towards the end. What is the maximum minimum numbers of the cell phones sold in a day? Well, the maximum is 4, maximum is 19, and the minimum is 4. Okay, 4 and 19. What is the typical number of cell phones sold? Well, it looks like it's probably going to be, this is 4, this is 8, 9, 10, 11, 12, 13, 14, 15, 16. It looks like, if they're asking what's the typical number of cell phones sold, I would probably say 12 right in this area, because notice 11, there's quite a few. Looks like 23, or there's quite a few here at 12 cell phones. So it looks like I would safely say, what is the typical number? I would say is around 12. Probably that's the median anyways. Okay. So again, taking a look at data, and then what is it telling us about the results? Now here we go. Let's do this one. Number 5. The first row of a stem and leaf chart appears as follows. 62, 1, 3, 3, 7, 9. Assume whole numbers are values. Wow. Okay. What is the possible range of values in this row? Okay, so remember, a stem and leaf chart appears as a specific segment of a group of data. And here they're showing us that the 62 is the number of observations, and the values are 1, 3, 3, 7, and 9. So what I would like you to do for Wednesday is I'd like you to go back to the textbook and try to determine what is the range of values of this specific row of data, how many data values are in this row, and list the actual values in this row of data. Where is this information, or how is this information allocated in this stem cell? Gives us a good example of stem cell. So I want you to go back and take a look at that, and this will be the first problem we review, and then we'll look at 11, 12, and 13 on Wednesday. Okay. So take a look at question 5 for Wednesday and see if you can do that. I know there'll be a problem on the midterm in revolving this, because it just isolates some data and you are trying to interpret that data, understanding what a stem left chart appears and how to determine that information. So take a look at that for Wednesday. I want to go back to a couple more points from chapter 4. So we'll look at 5, 11, 12, and 13 on Wednesday. And here is 11, 12, and 13 here. In case any of you do not have a textbook, there's the information there. And then on Wednesday, we're going to look at how to determine the quartiles, 25%, 75% of a series of data. Make sure you get a handle on that one. Okay. Now, the last part of chapter 4, which will set us up for future chapters, is to understand a concept called correlation coefficient. I know that's a mouthful. It's a statistic that can measure the direction and strength of a relationship between two variables. You're either -1 or +1 in the relationship. Are you positively skewed or negatively skewed? If the relationship or the correlation coefficient is 0, it means both numbers are exactly the same. This is another way of beginning our discussion and look at standard deviations, how data differs between the two averages. And that's what we're doing here. So the correlation coefficient is a way of determining the range between two variables. So let's say we're plotting some data and the correlation coefficient is -1. That means if we were plotting this data, the line would have a slope of left to right down. It would be what is called a negative slope. And it would be a negative correlation. In other words, negatively skewed, as they say. If we were looking at an area where the correlation coefficient was +1, that line would go right to left, up, and would have a positive slope in this format. And it would be called a positive correlation in relationship between the two data. Again, this is a way of measuring consistency in the data. And we need to start looking at it in these arithmetic ways. Some of it's called a contingency table. For example, Applewood Auto Group's profit comparison. Here's a contingency table. It shows the relationship between profit and the dealership, above, below, median, profit. So here are two salespeople and the various relationship to above profit, below profit. 90 of 180 cars sold had a profit above the median and half below. In other words, here's the cars that were sold and how many of those cars made a profit, how many didn't do that well. The percentage rates of profits of the median are, in other words, 48% for Kane, Olin, and so on. This tells us a breakdown of the data between profit and loss of a variety of different cars. So when I say what a contingency table is, it's asking for a review of the data on the whole and what percentile that data falls in by that whatever group you're in. In other words, there's 180 cars sold and Mr. Sheffield had 42% of those cars sold at a profit. Tanista had 60%. But we're looking at as above the median, not below. So we're looking at 25, 20, 19, 26. 90 of the cars had a profit above the median. And what percentage was Tanista? That's 60% of that calculation. Just summarizes data in a different way. So we've taken a look at the relationship of beginning to take a look at how information is different, how that is called a skew, positive or negative. And you can determine that by calculating a correlation coefficient. And we'll do that mainly beginning in chapter 5, but this is the beginning of that definition here in chapter 4. And we've taken a look at some problems to understand the definition of what a graph is and how we can look at that graph and explain certain information and interpret that information. And what type of graph? Is it a dot, a plot, and how that information tells us in relationship to overall data in the analysis. And that's what we're looking at in chapter 4. Now, I'll bring this back up. The other thing I wanted to end our class today on is, if you notice in your Blackboard that I have on the screen here, this is something we're going to be doing beginning after the midterm, but it's a good place to start because I know some of your other classes are going to be getting into this pretty soon as well. Notice this file folder here called Library Guides. Library Guides. And here's a section of the University of La Verne Wilson Library that you can find information and data in regards to statistical tools and information. It's called Library Guides. If you're taking accounting, your professor probably has your accounting class set up for accounting information in the library. If you're taking writing or a science, hopefully your professor has that set up where you can go to certain sections of the library and look for information. Yes, it's important to be able to physically go into the library and find data and go to a librarian and look for information. But here you can also do it through the Blackboard, through the library website, and find statistical information and information concerning the data you're looking at. And so that's why I wanted to show you this. Is down the road, we'll be doing some work in take-home assignments, examinations and quizzes, where I'll be asking you to look up certain information. And you can use these areas of study and information to find data from the library. And I wanted to show you this person's name here, Miss Linda Gordon. She is your business librarian. And you can email her, call her, or visit her in the library. Her office is in the library. And if you are working on a business paper, if you're working in statistics, if you're working in accounting, if you're working in any type of business-related administration topic, Miss Gordon is your contact if you need help. Now, naturally, you can go to your professor. Excuse me. You can go to your professor and get information, and they can point you in the right direction. But if your professor's busy or you need something pronto right away, Miss Gordon is available to help you find anything in the library that you need to find. And here's another thing she can help you with. I know in one of my classes, not this one, but some of the students were having a difficult time with their laptop. It was older, and it wasn't being able to use and go to download information very well. You can go to the library and get a laptop for the semester. They will give you one. It's like renting it. You don't have to pay for it. They will give you a laptop. Let's say your laptop is old or not working very well. You can go to the library and they can give you, if available, and I think there are some still available, to get a laptop. If you need a laptop for a weekend, or you need a laptop for the semester, or do you need a laptop for a class, you can get a laptop from the library. I don't know if you were aware of that. So now that we're beginning our 6th week and beginning to get a little bit more complicated and technical in some of our work, it's good to know that you can go to sources in the library and an individual with a face and a name and ask them questions for help in locating data. And her name for our group is Miss Linda Gordon. And there's her contact information right there. Also, the library has a chat service where you can just go on like we're doing here and type in a question and chat with somebody. Hey, where is this? I can't get a hold of Miss Gordon. Is she not in today? What's going on? So you can do that as well. So just another source of information that you'll be using, especially in all your classes, especially if it's business related, going forward, is using the library, and you can use that library guides file folder located in Blackboard to do that. Now, if you want a specific question, say Mr. Hasse wants me to find this and this and this, you can, hopefully your professor will show you point you in the right direction of what statistical information to use in the library. But again, this is a source of information and that you can use. I think one of the great things that we have going at La Verne now, compared to a lot of institutions I'm aware of, is our library has totally changed during the course of the pandemic from a hands-on visiting library to a digital internet library. You can get everything you want digitally and through the internet with our library. And that makes a better source of information. You can still go visit the library and study there and get information, but also they're up to speed on the digital platforms of everything you need to study. So that's something that's important going forward, and you all should be aware of the library services and what they can offer you. Okay. Let me stop right here and see, does anybody have any questions or concerns of today's topics or what we've looked at? How about a thumbs up? Do you know how to put a thumbs up to make sure you tell me that you're all alive out there? How about going and giving me a thumbs up? Do you know how to do that? No? No? Okay. There's Ryan. Thanks, Ryan. You're living. Thank you. Good to see that. All right, Ryan. Thank you for the thumbs up. That's helpful to me. All right. So as we move into our Wednesday Zoom session, we will have problems 5 through 5, and then 11, 12, and 13 we will review in class on Wednesday. I'll also review the quiz that you posted over the weekend, because you'll see those problems again in the midterm examination, and we'll review those problems on Wednesday as well. Now, even though I have COVID and I can't come to class, I can't come to campus until probably Thursday, you can still contact me if you still want to talk to me. We can still have a Zoom session individually. You can still send me questions. It's just like I'm there and just physically not there. So please, if you need anything this week, be sure to let me know. All right, everybody, if there's no other questions, and I got a thumbs up from Ryan, I think that'll be it for this morning. Oh, we got some chat questions here. Let's see, make sure chat. Oh, Emily, good job. Thank you. All right. Jonathan, great. Thank you. Thanks, Natalie. All right, appreciate that. It's kind of I didn't know if everybody was out there okay. Very good. Thank you for doing that. And I'll post this video recording of this lecture later on today after I get it processed. And again, I appreciate you coming on time and in force to class this morning. It's important that we continue the mojo of this class, even though you got a professor for the first time in 3 years has gotten sick. My streak is broken. So thanks, everybody. Have a great rest of the day, and we'll see you all Wednesday morning. Adios.